So whenever we have a rational function, so we can find the limit by dividing each term in the numerator and the denominator by the highest power in the denominator. So like in this example, we have a rational, we have this divided by this. So what we can easily, we should just look at what is the, because what is the highest, because let's for instance say we want to compute this limit. So this will be 3 times infinity square plus 4 times infinity, a very large number, plus 5 over 2 infinity square plus 1. So this is just infinity because we are multiplying infinity by a number. This is infinity plus 5 over here. Everything here will be infinity plus 1. So infinity, a very large number plus a very large number is just a large number. So that's just infinity. A very large number plus 1 is a very large number. So that's infinity. So we have infinity over divided by infinity, which is just undefined. So that's why in this case, in order to find this limit, we usually have a method to do it. That is, we look at the highest power so of the denominator. So if you have this, let me write it again, 3x squared plus 4x plus 5 divided by 2x squared plus 1. Then look at the highest power of the denominator, which is x squared here. So in this case, it's this x squared. So we just divide everything by it. So it's just the limit of x tends to infinity. Then here we have 3x squared, we divided by x squared, plus 4x, we divided by x squared, plus 5, we divided by x squared, divided by here we have 2x squared, we divide this by x squared, plus 1 divided by x squared. So we divide everything by x squared. And this is just the limit of x tends to infinity. Here x squared will go into x squared 1. 3 times 1 is 3. Plus here we'll have 4. X will go into this 1. So we'll just have 4 over x. Here will be 5 over x squared. Divided by here x will go into x1. 2 times 1 is 2. Plus 1 over x squared. And here now we want to compute this limit as x tends to infinity, and this, the first one is just constant, so it will just be 3. Here 4 divided by infinity, a very large number, so this will just be 0 because just we are dividing 4 by a very large number, so it will just be 0. Plus 5 divided by infinity, large number, this will also be 0 over 2 plus 1 over infinity squared, that is 1 divided by a very large number, which is just 0. So we'll just be left with 3 plus 0 plus 0 is 3, 2 plus 0 is 2. So our limit is 3 over 2. So here we have another example, the limit of x tends to infinity. You know, like in the previous example, this we can easily approximate it by the highest power in each. So I can easily approximate it by x tends to infinity. So in here, the highest power is this, minus 24x squared. So I can easily approximate it minus 24x squared over 6x cubed. And this is just, if I substitute infinity here, it will be the limit of x tends to infinity minus 24 infinity square over 6 infinity cube. So this will just be minus infinity over infinity and plus infinity, and this is undefined. So that's why in order to solve this, it's better we kind of use the the other method and divide everything by the highest power here. And for this case, the highest power is this of in the denominator is this s cube. So then we'll have a limit as x tends to infinity, 2x, we divide this by s cube, minus 24x squared, we divide this by s cube, minus 7, we divide this by s cube, divided by 6s cube, we divide this by s cube, minus 5x square, we divide this by s cube, and this will give us a here x will go into this, we'll just be left with x squared. So we'll just be left with lim x tends to infinity of 2 over x squared minus this will goes into this, so we'll just have minus 24 over x minus 7 over s cubed divided by here, this will go into this one, so 6 times 1 is 6 minus this goes into this ones into twice, so we'll just have minus 5 over x. So you'll be left with so, and this is if we take x to infinity, this is something divided 2 divided by a very large number, this is 0, this will be 0, we are dividing by infinity, so we'll just have 0, and 6 minus 5 over something 0, so we'll have 0 over 6, and this is 0. So in this example, we use a similar method by dividing by the highest power. So this example will just be limit at x tends to minus infinity. So we'll have 4x squared. Look at the highest power here in the denominator. So the highest power in the denominator here is this x. Sorry, I kind of is this x. This is the highest power in the denominator, so we are dividing everything by x. So this we say this divided by x minus 7x divided by x divided by 5x divided by x minus 2 divided by x. So, and this will be the limit of x tends to minus approaches minus infinity, x goes into this one, so we'll just be left with 4x minus here x goes into this one time, so we have 7 times 1, which is 7, divided by x goes into x1, we have 5 minus 2 over x. So, and here at x tends to infinity, so this will be 4 times minus infinity, here minus 7 over 5 minus 2 over minus infinity. This is just 0 because 2 is 2 divided by a very large number, but I can even write it. So 4 times infinity, this is just minus infinity, is just 4 times very small number still, minus 7 over 5. Here something divided by minus infinity is just 0. So this is 0, and then we'll be left with minus infinity minus 7 is just minus infinity divided by 5 minus infinity over anything is just minus infinity. So our limit is minus infinity.